Assalamu alaikum. We have discussed last time the force energy relationship and the important concept that we have said work will be done on a body if energy is transferred from one body to the other. And we have solved two examples and we have seen how work done is negative and positive. What does it mean also? Okay, the meaning. The force and the distance or the displacement, if they are in the same direction, the work done will be positive. That means the body will gain energy. And if they are in the opposite direction, the work done will be negative, and that means the body lost energy. And I'm waiting for your answer also for these three questions. The two questions in your textbook and the one question from the entrance exam. Only few students gave me their case solution. Okay, let us continue today on the other concept, which is calculating the net or resultant work done. If there is different way of understanding of the work done, that means if the force and the direction of the motion are in the same direction, we have said it is positive. If the other way, negative. So what will happen if we have a number of forces on a body? How we calculate the net work or the resultant work? Here it is mentioned, the net or resultant work. If we have more than a force applied on a body, we can calculate the resultant force in two different approaches, two main approaches. Okay, we can calculate the net or resultant work in two approaches, approach 1 and approach 2, as mentioned in your notebook. The first approach is simply you will calculate the work done by each force individually. Each force, that means force 1 times distance 1 times cosine of the angle, one work done, then the other also the same, and after that you will sum it up. After that you will sum it up, or you will sum them taking the signs into account. That means the direction, the positive to be positive, the negative to be negative. This is one way. So if these all forces are positive, then the work done will be positive. If there are some forces positive work done, or for the other forces there is a negative work done, so you will sum up them with consideration of the sign. The second approach is simply calculate the resultant force first, as we have as we already did this in the chapter before, which is chapter 4. So you will calculate the resultant force. After this resultant force calculation, then you will calculate what? The work done, the resultant work done. Because the force done, the force times the distance, the resultant distance will be your resultant work done. Look, simple example. The first and the second examples merged together. That means if the same car, which was in example 1 and example 2, remember, there is now, the car is now accelerating forward, but a friction is working against the motion of the car. Friction is working against the motion of the car. A force of 300 Newton is applied forward on the car, traveling to 20 meters forward. A frictional force of 100 Newton is act on to opposite motion of the body, opposite to the motion of the body. Then it says calculate the net work done. You see, we have two forces now, applied force and frictional force. The applied force is in the direction of the motion, the frictional force is against the direction of the motion. Now, how we calculate? We have two forces, force 1 and force 2. Can you try, students, this, and you can see the answer in the next page. We can see the answer in the next page. Look, the answer. First, you have to extract the givens. We have now three givens. The force applied, that means the two forces, the direction, which is one with 90 degree and with 180 degree, and the other 0 degree. So the formula is the common formula, which is force distance cos theta. We can use one of the approaches. Now here you can use one of the approaches. For example, in this solution you can see we have applied the first approach. That means we have calculated the work done by each forces. The first work done, which is by the applied force, is the applied force times the distance times the angle, which is 0 degree. Because why 0 degree? The applied force and the direction are in the same way. So we have 3000 joule of energy. 6,000 joule of energy. 6,000 joule of energy. The frictional force also has a work done which is opposite in direction. That is why we have 180 degree. So the work done by the frictional force is negative 2000 joule of energy. So the net work, that means the resultant work, is work applied plus work on the frictional force. So keep the sign of the frictional force to be negative. The resultant force and the resultant work done by this force is 4000 joule of energy is gained by what? The car. It is positive, means the car gains a resultant of 4000 joule of energy. Now we have important 2 pointers. One, forces that result in positive work increases the energy of the object. This is our conclusion. Okay, the energy of the object, while forces that result in negative work results or reduces the energy of the object. The other point is the forces are vectors, but work is scalar quantity. Okay, if you have any question, if you have any confusion on the discussions and the examples and also on your homework, please ask. Okay, and we will discuss the other important portion, which is kinetic energy and the other forms of energy, in the next video. Thank you so much for your follow-up. Goodbye.